Okay, let's get started with the machine learning series. Let's see what I have prepared for today. For this series, in general, we're gonna cover many different topics that have to do with machine learning conceptually and hands-on coding, image classification, object detection, image semantic segmentation, and many other things. Today, specifically, we're going to see an intro to machine learning to this series. We're going to go and get hands-on coding with Python, Anaconda, and Jupyter notebooks. This is something that we're going to be using throughout the series and that you're going to need to know at least a bit to be able to use the things that we learned here. And we're going to look at some of the main machine learning frameworks. For the coming weeks, some ideas that I have, I really want to prepare a sketches dataset with my drawings for StyleGAN and maybe try to train that in Google Colab or Runway. We'll see what those are. And also building a suggestive drawing app. We previously did a prototype in Glitch, but I would like to do something a bit better, maybe using web technologies like React, or maybe continuing the work that I did previously for the iPad. Many of you have asked me what I would recommend for getting started with machine learning and artificial intelligence. This is my Bible. This is what I'm going through. I actually have it. I have it here. So this is the book that I would recommend you to get if you want to get hands-on with machine learning. It's a really heavy and long book that I haven't gone through entirely, but this is something that is helping me interiorize many concepts, many terms, and also algorithms, what they're good for, when to use some of them, and how to get to actually training them and using them. As you can see, it says hands-on machine learning with scikit-learn, Keras, and TensorFlow. We'll see a bit more about what those are later, and in particular, this book is for TensorFlow 2. So previously they had the TensorFlow 1 version, but they just updated this year or at the end of last year for the latest TensorFlow API. You have a link there. So you have a link below here at nono.ma/book/hands-on-ml, or you can simply Google the name and find it. They have a Kindle version and also a physical version. And something I didn't add here, but that you can also see if you go to nono.ma/ml, there is a list of resources. We can actually see them right now that I have on my website that I put online for some people who ask me about recommendations on what to look at if they wanted to learn machine learning, right? So how to get started with machine learning. I update this from time to time. So we have here Stanford cheat sheets. These are really useful PDFs put together by the Amidi brothers. So Afshin and Sherving. I'm not sure if I'm pronouncing that right. And you can see there's a lot of concepts that we're gonna see in these videos that are shared in here. So you have, for instance, if we go to convolutional neural networks, there are many diagrams here that can help you understand many of the concepts that you need to know, or at least understand, if you want to get to use machine learning and have a good understanding. Things like ReLU or activation functions, or many of these things, hyperparameters, filters, connected layers, disconnected layers, convolution layers. These are all concepts that you need to know and are good. Okay, so these charts are there also on the links on this page. We also have the hands-on machine learning book that I just mentioned, so you can learn more about it in here as well. I also recommend usually to go to open source tutorials that maybe the TensorFlow community has created, or go to machine learning networks that have been open source that you can learn from, and the paper publications. Friendly user interfaces. This is something that I haven't talked about yet, but Runway and other platforms are trying to make machine learning more accessible for creatives. And maybe you can get to use machine learning without having to know how to code. In this series, we're also going to use these sort of tools, but we're also going to get hands-on with coding. I actually have an interview with Cristobal Valenzuela, one of the co-founders of Runway. There is a talk here that explains a bit more in depth how I understand the use of those tools in design. Courses, I'm following online this course, I'm watching the classes, and it's really instructive. So I'm learning a lot about convolutional neural networks. And these other two I haven't gone through, but seem really promising. Some other videos I have, some resources. So yeah, that's here at nono.ma/ml. Okay, let's get back to our slides. So what is machine learning? This is something that maybe you've heard of, maybe you know how to describe it, maybe you don't. I tried to come up with a quick description based on this book. Machine learning is the science of adjusting the behavior of programs that learn from data by providing them with examples. This means that there is a program that is able to change how it works and what outputs it provides just by changing the data samples that we're giving it. This means, for instance, if you have an algorithm that recognizes faces and recognizes 3 people, let's say Mark, Peter, and John, then you can retrain it and adjust the behavior to recognize different faces by showing it now 3 pictures of, I don't know, maybe Maria, Peter, and Pablo, for instance, right? So it's an algorithm that gets to adjust the way it works just by samples, and we don't have to change one line of code. The writer of this book defines it as the science and art of programming computers so they can learn from data. And a more general description from Arthur Samuel back from the 1950s is that machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. The part explicitly programmed here is super important. It means when you explicitly program a machine means that you're hard coding or typing with your hands all the instructions, all the rules or algorithms that the program has to do. Here we just have a general approach or a general set of behaviors that then can be adjusted. For instance, that behavior could be recognize objects as images or recognize exactly where objects are on an image, but not recognize that a car has maybe a wide proportion and a low height and then a certain shape, right? It learns from the features on the image, on the data samples. Hey, it's Nono. This video was part of the machine learning series. Please go ahead and like it if you'd like to see similar content on my channel. And subscribe if you want to get notified when I publish new videos or when I go live. Thanks so much for watching. I'll see you next time.